Hey everybody, this is Larry. This is me doing week 3 of the Leetcode June weekly premium challenge. Hit the like button, the subscribe button, join me in Discord, let me know what you think about this one. And this one we have yay, an unsolved Larry problem, a problem that I've not done before, so I'm very excited for that. 663, Leetcode tree partition. Not to get started. Given the root of a binary tree, return a true if you could partition a tree into 2 trees with equal sum of values after removing exactly one edge from on the original tree. Okay, I mean, yeah, I mean, I think this is, I don't know if I would call it standard. Oh, I dropped stuff. It scared me. I don't know if I would call it standard or whatever, but I think it's standard once you rephrase this problem is why I kind of like, okay. So what happens when you remove the edge, right? That's the question. And I think let me. I was like debating. I was like trying to figure out, can I explain this without drawing? The answer is probably yes, but I feel like someone's gonna be like, oh, why didn't you just draw this? So give me a second. Let me bring up the drawing board. And here. Oops. How do I? Okay. Right. And the idea is really simple, to be frank. Let's say you have, oh, my pen was backwards. Let's just say you have this tree or something like that, and it doesn't have to be this tree. Then now, what does it mean by separating into 2? Well, when you remove an edge, what does that mean? That means that now you have 2 things. One is the subtree, which is everything is intact, and the other is, well, what's left of the tree, right? Okay. So far so good. We're just talking about the definition of the problem, right? Well, the thing that makes it a little bit easier is that, okay, well, we still have this. This is easy to do because you're just getting the sum of a subtree. Here it's a little bit tricky if you're trying to like do some whatever. But the easy idea is that, okay, well, we can also do the sum of the subtree of everything, right? The entire tree, rather, the sum of the entire tree. Then now, the red piece. Well, I clicked it correctly anyway. The red piece is just equal to. I mean, hopefully you see where I'm going. The red is equal to the blue part. Okay. Is this the right color? It's a little bit different actually. All right. It's equal just to blue part minus the black part, right? So that's basically the idea, is that, you know, you right, and honestly that's it. You get a subtree. I mean, you could do it in 2 passes probably. You may even do it in 1 pass if you're really slick about, I don't know that you can, to be honest. I mean, you can, I don't know, maybe you can do it in 1 pass, but I don't think it matters that much for a tree. For cache locality reasons, I don't think, or like the cache locality reason in which why you normally do in 1 pass, for a tree doesn't really make sense. I mean, maybe there's a cool way of doing it, but for now, let's not care, right? So here, maybe we could get like the I don't know. You probably don't even need 2 functions if you really care for, but let's just do it in 2 functions, just so that, you know, whatever, right? So get sum of node, right? So if node is none, then we just return 0. Otherwise, total is equal to get sum of node.left plus, oops, plus get sum of node.right plus, what's it called? Node.value? Yeah. Okay, we don't even need the total. So this is like very standard stuff, getting the sum of the subtree. So then maybe we have total is equal to get sum of node of root, right? And then now all that means is that maybe we have like a find target or something, right? Of total divided by 2. And of course it has to be, if total mod 2 is equal to 1, then just return false because, well, it's odd, right? Otherwise, this is the same idea. Oh, and you have to give it a node, right? Of course. Yeah. And then if node is none, then we just return 0. Maybe this one could be a little bit awkward, but left is equal to find target. Oh, I don't know why I wrote it this way, but here is target, right? Find target node.left target, right? If left is equal to target, then we return true, kind of return true. You don't, it's hard to return true. I mean, you can return two things here, but maybe the easier for now is just have like a global variable of, not good, that's just called found, right? I mean, it's not global in the Python sense, it's technically non-local. So here we have non-local found, and found is equal to true, and then we return, well, we don't return actually. We do return, just not there, right? And then we do the same for the right side, right? I just paused over there because I'm like, maybe I didn't really need to maybe I could reuse the first function, but whatever, it's fine, right? And then now at the end, again, we just add left plus right plus no dot value, which is very similar to this, right? And we always set found to true if found is equal to true. And then we just have to go find target root total divided by 2, and then return found, right? And that should be good. Give a quick submit. Yeah, ooh. Huh. I mean, I see why I didn't know that. Okay, so first of all, the reason why it's incorrect, I honestly thought it would be correct, to be frank. Two things about this. Let me actually step back for a second before I address the wrong answer. The reason why I didn't talk about complexity, etc., is because I thought it'd be too traversal, and having too traversal is just linear, right? Linear time, linear space. I'm not going to worry about what n is, and as a result, I didn't look at the constraints. And if I did, then I would have seen, or maybe, I don't know, who knows, that this actually has a negative value. And the reason why this no longer works is because now, well, we have negative value, right? Yeah, and this is a negative value thing. How is this? Oh, am I just being dumb? I am being dumb. Am I always returning true? Is that the... No, this returns false. The reason why this returns true is actually because the sum of the root, yeah, I mean, basically the entire tree, because the sum of the tree is total, right? And total is equal to 0. So that means that we're searching for target is also 0, because 0 divided by 2 is 0. And then now the entire sum is, yeah. So the TLDR is that, no, I mean, because I thought that, yeah, because the idea is, or sorry, I'm like debugging in my mind a little bit, but I think that the reason why it's returning true is because it tries to, I was going to say maybe the root subtree, but no, I think this doesn't actually consider the root this way. We only consider the root and the left, right? So why is it returning true then? Because I thought that maybe if it tries to cut off at the root, because the root is the subtree from the root, which is the whole tree, is equal to itself half, right? So that's why this is wrong, which is actually kind of sad. But because if it was all in positive numbers, it would be correct, but now it is not. But I don't think that's what I'm doing here, right? All right, we can print it out real quick though. Print node target left maybe. Just run it real quick. So we had the -1, no, -1. Oh, actually, that's not my interpretation of what happened. Well, I mean, it's not. I knew that my initial interpretation was wrong, but basically, I was just being lazy. Okay, fine. That's silly. Basically, I don't handle the leaf node because here it returns 0, and then because of that, that is wow. I mean, yeah. So for leaf node, or even it doesn't have to be a leaf node, right? Because the total sum of the tree is 0. So even if I have like just non-leaf nodes, even if I handle leaf nodes, this would be wrong. Because if I do, like, in a way, you could imagine I go, okay, if node dot left is none and node dot right is none, then we return node dot value or something like that, right? But that still doesn't fix it. It fixes for this case, I suppose, right? But you can imagine another case where it's something like I don't know, something like this, and it was still, this would be oh, because the subtree, no, maybe not rooted at 0. Yeah, right. And the reason is because now the entire tree, the sum is 0, your target is 0, but then now now the sentinel value is giving you an issue, right? So then now we have to figure out a way to address it. Maybe we could just do return a count as well of the number of cells, right? So here we do something like this, and we could remove this. So then now if left is equal to, okay, so left is now 2 components, and then maybe left and left C for left count. So then this and left count is greater than 0, meaning that the number of cells in that subtree, because when you cut off an edge, that means that is in that subtree. So if that the number of counts in that subtree is greater than 0, then you have that. Otherwise, this is the sum. You have left C plus right C plus 1. And hopefully that should be good for this case. Looks okay. Let's give it a quick submit. But that's a very wonky, kind of sad that I made these mistakes, but I really also just didn't realize we have negative numbers because I didn't really look at it. So maybe the first lesson learned is that look at the constraints. Always look at the constraints. Do not assume, which is something that clearly, even with decades of experience in competitive programming, I still made a mistake this way, which is kind of sad. Which is why I'm sad. But yeah, again, this is linear time, linear space. This is the regular traversal, regular tree traversal. So I'm not going into that much detail into that. But yeah, that's all I have for today, though. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.